Your TensorFlow is ignoring your GPU. In this episode, we turn it on. On Windows, the official path is WSL2 with CUDA 12.5. Check your GPU, install Linux in 10 minutes, and watch your training time drop. Let's get started.
Quick recap. Episode 4 gave you TensorFlow 2.21 on Windows, running on the CPU. It works, but your NVIDIA GPU is sitting idle. Here is the catch. TensorFlow dropped GPU support on native Windows after version 2.10. The official fix? Run TensorFlow in WSL2, the Linux environment built into Windows.
Why bother? A CPU has a few powerful cores. A GPU has thousands of smaller ones, built for parallel math. With cuDNN, NVIDIA's deep learning library, TensorFlow hands the heavy matrix work to the GPU. Real results: a small CNN trains 4 to 6 times faster.
ResNet-level models can be 12 times faster, and in surveys, up to 30.
Here's the trap everyone falls into. You run the standard check on Windows, and only the CPU shows up. That is not a bug. TensorFlow 2.11 and newer simply have no GPU build for native Windows by design.
The dead end is the DirectML plugin, discontinued at Python 3.10. The official path is WSL2. Let's build it.
First, check your hardware. Open PowerShell and type nvidia-smi. You want 3 things: an NVIDIA GPU, Pascal generation or newer, a driver at version 5.55 or later, and the CUDA version row showing 12.5 or higher.
If nvidia-smi is missing, install the NVIDIA driver first, then come back.
Now install WSL. Open PowerShell as administrator and run WSL-install. One command enables the virtual machine platform, installs the Linux kernel, sets WSL2 as the default, and installs Ubuntu. The messages appear one by one, and then it asks for a restart.
Reboot when it says so.
After the reboot, Ubuntu starts for the first time. It takes a few minutes to install, then it asks you to create a default Unix user account. The username does not need to match your Windows name. Type 1, then a password.
Important. Nothing appears while you type the password. That is normal. It is called blind typing. Then check with Huami.
Back in PowerShell, update WSL with WSL-update and check the version. Then run WSL-L-V and confirm the version column says 2. WSL2 is required for GPU access. Now go back into Ubuntu and type nvidia-smi.
It works inside Linux because WSL shares your Windows driver. The GPU is now visible in both worlds.
Time to install TensorFlow for GPU. Inside Ubuntu, check the Python version. Ubuntu 26.04 ships Python 3.14, but TensorFlow 2.21 supports up to 3.13.
So install Python 3.13 from the DeadSnake's PPA. Create a virtual environment, activate it, and run pip install TensorFlow with the and-cuda extra. That one command downloads CUDA 12.5 and cuDNN 9.3 automatically about 3.2 gigabytes of NVIDIA libraries.
No manual CUDA install needed.
Now the moment of truth. Run the same check we failed in Scene 4. List physical devices, GPU. This time it returns the GPU. That green line means TensorFlow can see your graphics card. One tip: enable memory growth so TensorFlow doesn't grab all your VRAM at once.
Now let's use it. The exact same CNN from episode 4, 3 epochs, batch size 64. On the CPU, 1 epoch takes over 12 seconds. On the GPU, about 2. Nearly 6 times faster for a small model. And the gap grows with bigger networks.
One honest caveat: Tiny models can be slower on GPU, so use real CNNs and bigger batches, and keep your files in the Linux home folder, not on the Windows drive, or disk I/O will slow you down.
If it breaks, here are the 3 fixes. GPU not detected in WSL. Confirm WSL-L-V shows version 2, and that the Windows driver is installed. Missing cuDNN libraries, reinstall with pip install upgrade TensorFlow and and-cuda.
Driver too old. Update NVIDIA drivers to version 5.55 or newer. That's the full journey. Check, install, verify, train. If this helped, like, subscribe, and comment. Next episode, we fine-tune with Laura on your own GPU.